Okay, this is my second attempt at this video since the first one had no audio. I'm just going to leave the notes that I created here and we'll just talk about them until we catch up again. So we're going to discuss polynomials. So what I've written here is a polynomial expression, a to the n times x to the n plus, and the next term here would be a to the n minus 1, x to the n minus 1, so on and so forth, until we got to the term a2 x squared plus a1 x1 plus a0. So this is a general representation of polynomials. Notice all the exponents are integers. This a0 could be multiplied by x raised to the power of 0, but x raised to the power of 0 is 1, so we always usually write that a0. So the first term is probably the most important term in a polynomial. The exponent of the first term will dictate the degree of the polynomial, and this coefficient sometimes has importance. It's leading coefficients. All the a's in this term, all the a's are constants, and they're called coefficients, and your x's are variables. Okay, so then we have some examples of polynomials down here. So the green equation here is a fourth degree polynomial with each term represented, 6x to the fourth plus 2x cubed plus x squared plus 8x plus 11. So I wrote here it's fourth degree, and there are a total of 5 terms. So each of these groups is considered a term, and that's important to understand that because it's going to dictate how we add and multiply our polynomials together. Okay, here's another one. This is a second degree polynomial, 5x squared plus 4x plus 1. Has 3 terms. Sometimes we call that a trinomial. This one down here has just 2 terms, so it's still a polynomial even though it's missing the x term. But x squared minus 9. So again, this is also second degree, just like this, same degree, but this is only 2 terms. So often we call that a binomial. Okay. And let's talk about adding and subtracting binomials. So I have 2 binomials here, or polynomials. I have 2 polynomials here. They're actually trinomials. One's third order, third degree, and the other one's second degree. But they each have 3 terms each. Now they don't have to have the same number of terms to add and subtract, and we'll see why. Because what we need to do is we need to combine like terms. So the first thing we're going to do is we're going to add and subtract the cube terms, because I'm just going to start with cube because it's the largest. You don't have to if you don't want to. You can choose any term, but so I'm going to put a check mark so I see that I remember to do it. Now this is a subtraction here, but it's a subtraction of a quantity. Now what you could do is you could write this out where you distribute that negative in here, and it would look something like that, whereas you'd have 3x squared plus 2x, the same thing over here, plus 9. Or you could do it in your head, however you do it. But our first term is the cube term, so minus 2x cubed. Okay, there's no other cube term over here, so the cube term over here is 0. Okay, next we have our square terms. So I've got 2, I've got this, and I've got this. So I've got 3x squared and essentially plus x squared. So that's plus 4x squared. You add the 2 of them together. 1x squared plus 3x squared is 4x squared. Okay, now the x's. Here we only have 1, so plus 2x. And finally, our constants, I have 9 plus 6 is 15. So even though this was a subtraction, a lot of the terms end up being positive just because of the signs that were in front of the terms. Okay, let's talk about multiplying 2 polynomials together. Now, when we multiply 2 polynomials together, we can use the distributive rule and just distribute these terms. So I could take, for example, this term, multiply it by the first term here, this term, multiply by the second term, this term, multiply by the third term. Then I would take this term, multiply by the first term, this term, multiply by the second term, this term, multiply by the third term. So in essence, it would look something like this. I could take 3x and multiply through the 2x squared plus 3x plus 8. And then I can add to that the 2 multiplied by 2x squared plus 3x plus 8. So ultimately what we end up with then is 3x times 2x squared is going to be 6, the two coefficients multiply, then the x's multiply, 3x cubed plus 9x squared plus 24x plus 4. 2 times 2 is 4, x squared. So this is only multiplying the coefficients, plus 6x plus 8. And we usually just don't leave it like this. We usually group like terms. So the x squared terms are like, and the x terms are like. So let's go ahead and group our like terms to finish up here. So 9x squared plus 4x squared is plus 13x squared. And then 24x plus 6x is plus 30x plus 8. There we go. That looks good for an answer. So often we're called on in science to multiply two linear equations together. And when we do that, these are each first degrees, because x is raised to the 1 power. But when we multiply these together, you're going to see we're going to get a second degree equation. And one way to do this is you take this times this and this times this. So we got 3, or I'm sorry, let me go work it out long. 3x times 2x, and then we've got plus 3x times minus 1. Then we come down to the bottom. Well, not necessarily the bottom, but it just looks like it. Then we have 6 times 2x, and then 6 times minus 1. And when we work these out, we're going to get 6x squared minus 3x minus 1 times 3x minus 3x plus 12x minus 6. Let's group our two x's. So we're going to end up with 6x squared. 12x minus 3x is plus 9x minus 6. All right, so this guy, again, second degree. It's a trinomial. But anytime you have an x squared polynomial like this, we'll often call this a quadratic equation. Quadratic equation. Now, what's neat about this is often you can get a quadratic equation, and you can find, not always, but often, you can find what we call the factors of this, which we already had over here. So these are our factors of this quadratic equation. So that's another way of looking at that. Now, the